Hey everyone! We have seen Python's built-in data structures like list, tuple, and dictionaries. In real world, when you start working as a professional software developer, there may be situations where you may have to implement your own data structure. Even if you don't need it in your professional career, companies usually ask about this in the interviews and coding challenges. So starting from this video, we are gonna look into different Python data structures and we are gonna implement them on our own from basic data structures that Python offers. In this specific video lesson, we are gonna take a look at one of the most fundamental data structures in Python, stacks. You can imagine stack data structure using stack of books. Let's say we have 5 books and we want to stack them one on top of another. Once they are stacked one on top of another, when we want to get the last book, we first have to move all the other books away and then only we can access the first book we placed on the stack. This is exactly how Python stack works. It supports few operations. When you want to insert new element, or in our example, when you want to stack one more book, that operation is called push operation. The reverse of that is going to be the pop operation to take out the first book from the top. There is also peek operation, which allows you to take a look at the name of the first book without taking it out from the stack. As you can see from our example of stack of books, the book you stack at first can be taken out at the last. So that's known as last in, first out. This is often abbreviated as LIFO data structure, LIFO. Similarly, if we push list of numbers 1, 2, 3, 4 and 5 into stack, when we want to remove a number from the stack, we first have to remove the last number. Then only we can access the number before that. That's last in, first out. If I want to add a number, I have to add it to the end of the stack. So let's start creating our own implementation of stack. It's quite common to use built-in data structures when you want to build your own data structures. In this video, I'm going to make use of built-in list data structure, but I will also create a separate video on how we can implement stack from scratch without using any built-in container data structure. So let's create our own stack class that can be used pretty much like a stack data structure we have been discussing so far. Let's create the constructor init method, and inside this method we create single attribute items. It will have all the items in the stack. We can use Python's list data structure to hold all the items in the attribute. So let's initialize it to empty list. For working with stack class, we need to implement 3 methods. Let's write down the basic structure of all these methods and then we are gonna fill up the implementation one by one. Def push, it takes an item and let's simply write pass as implementation. Def pop, this method takes out the last inserted element. Def peek, this method will be used to take a look at the last inserted element without removing that item from the stack. These are the 3 main methods we are going to implement. First of all, for push method, we can use Python list objects append method. So in the implementation, it will be self.items.append item. This will make sure that the new item is inserted at the end of the stack, means at the top. For the pop method, it should take out the last inserted element, which will be the last item of the stack. So we can return self.items.pop. This will remove the last inserted item from the stack and also return it. For peek method, we need to return the last item of the stack, but we don't need to remove that item from the stack. For that, we can make use of the negative index of the list. This can throw an error if the stack doesn't have any element. So we first need to check if the stack has any elements. Let's define a separate method isEmpty that will return either true or false depending on if there are any elements in the stack. In the implementation, we can return true if the self.items attribute has no elements. So we can check if the length of the items attributes is 0. In the peek method, we can use if not self.isEmpty, then only return self.items with -1 index. Let's also define _stir method so that we can print out stack object for our testing. Def _stir, and in the implementation we can make use of the stir method of list object. So we can return stir of self.items. Now it's time to test out our stack class. Let's create stack of numbers. First, let's create the stack object. Let's push number 10 into the stack. Let's insert second element 20. Print the stack to verify both values are inserted. Now push element 30. Let's pop the last inserted element, so it should return the element 30. Let's print it to verify. Now it should have removed the element 30 at this stage. Let's push one more element 40 into the stack. And finally, let's print the stack. At this stage, it should have elements 10, 20 and 40. Let's execute our code and verify. You can see that it has printed 10, 20. Then we pushed element 30 and we popped that last element, and that's why it printed 30. Then we pushed 40 and that's what it prints in the final stack printing. So our push and pop methods are working as expected. Let's also make sure that our peek method is not removing the last element but still returns it. Here I write print stack.peek. It should return the last element 40. Finally, let's print the stack again just to verify that peek method call has not removed the last element. Let's execute the code and verify. And sure, our peek method is also working perfectly. So that's just a simple demo of how you can implement your own data structure using Python's built-in data structures. I hope you found this video informative. If you like this video, give it a thumbs up and don't forget to subscribe to my channel. Also, if you have any questions about materials covered in this video, post it in the comment section below and I will get back to you as soon as I can. Thank you so much for watching this video. I will see you in the next one.